Well, good morning. This is your stats sensei, and we're going to look at two sample proportions for hypothesis tests. So a two sample hypothesis test for proportion is used to determine whether there is a difference between the proportions of two independent populations. That's the key word. And so we're going to start off with P1 equals P2 or P1 minus P2, indicating a claim of no difference. This is your null hypothesis. All right. And the two sample proportion is a hypothesis test is different from the confidence interval and for proportions, and it's different for means, because when we were doing with means, we didn't pool, and here we actually have to pool. Now the calculator is going to do this behind the scenes, but we're going to need to change some formula, and we are going to have to show a little bit of extra work, a little bit different work. So first off, the standard deviation or the standard error for a difference in proportions hypothesis test will be this. All right, and notice we have P hat C and Q hat C. We've not had that before. Really, that's P hat pooled and Q hat pooled, and some people make it notated as P hat P and Q hat P, but all of a sudden I start looking and that's not a PP on the paper, so I use combined. So P combined, Q combined, P combined, Q combined. All right, and notice these two are exactly the same, and the only difference is the sample size, N1 versus N2 being different. So basically, once you have P hat C, you have it for both parts of this. All right, now that's different than our standard error that we had when we were working with a confidence interval. With our confidence interval, we had P hat 1 and Q hat 1 over N1 and P hat 2 and Q hat 2 over N2. Here we have combined, all right? And the question is, well, why is that? Well, the reason it is because we believe that these two proportions are equal. Because they're equal, we know that if we increase our sample size, we decrease the amount of variation. And if we decrease the amount of variation, we have a more accurate results. So we combine our sample sizes. So P hat C is equal to the number of successes in 1 plus the number of successes in 2 over the sample size of 1 plus the sample size of 2. So it's either going to be shown as P hat combined or P hat P. I prefer to use P hat combined once again because I'm trying to cut down on the amount of PP on the paper. Please note, for AP statistics, this is not for all classes, but for AP statistics, we only need to pool for two sample proportion hypothesis tests. We do not pool for two sample confidence intervals. No pooling. We do not pool for means. All right. We do not pool for confidence intervals or means. All right. So please note, the only time we pool or have to pool is for two proportion hypothesis test. And the calculator will do a lot of this behind the scenes, but we will have to show this work. The calculator does that automatically behind the scenes and will calculate this value for us. So here is our formula, and I know that's a little bit small, so I'll try to increase that size. So P hat 1 minus P hat 2, well, that's no surprise, is in our numerator. This is a Z equals, because all proportions are Z. And then we have P hat combined, Q hat combined over N1 plus P hat combined, Q hat combined over N2. All right. That's our numerator. This is our denominator. This is our standard error part. Okay. And notice once again that that's different than what we've had before. All right. P hat combined, this is your formula. And we know that P hat 1 is X1 divided by N1, number of successes divided by the sample size, and same with P hat 2. All right. The conditions are going to run very much the same. And we should go ahead and take a look at our recipe. So in our recipe, we say P1 equals P2, or we could obviously do the P1 minus P2 equals 0. The alternative, it's not equal, it's less than, or it's greater than. We must make sure that we define them in context, all right? They have to be defined in context. We need to write the conditions. We need random samples for both because we have two groups. They need to be independent samples or independent populations. We need to satisfy the n is less than 10%. And then our samples for all of them, NP and NQ, must be greater than 10. This is our normality condition. This tells us we can use the normal approximation. Once again, this is our formula. And everything else follows just what we've done before. All right, and so here's our basic template. Our p-value is whatever we calculated. We reject the null. There is sufficient evidence at alpha to suggest that the true population proportion, that the difference of true population proportions is this, okay? All right, so let's take a look at running this. And by the way, it's gonna be really important that you use your definitions well. So suppose that in an early election campaign, a telephone poll of 800 registered voters shows 460 in favor of a particular candidate. So guess what? There's our sample size and there's our X. Just before the election, a second poll shows only 520 of 1,000. So we have a sample size, a second sample size, and we have a second number of successes. All right. At the 10% significance level, so this tells me I'm running a hypothesis test as opposed to confidence interval, because this is my alpha. Is there sufficient evidence to suggest the candidate's popularity has decreased? Well, this tells me my inequality. Now, how do I know that this is proportions versus means? Well, nowhere in here does it talk about averages. Nowhere in here does it talk about means. Nowhere in here does it talk about the X bar. So consequently, we have two values, so I can make a ratio of them. If I can make a ratio of them, I can work with a proportion. So my null is P1 equals P2. And I could have written this, and make sure you know how to recognize it. P1 minus P2 equals 0. Or the alternative, and we have a direction here, P1 is greater than P2. And it means the true population proportion of voters of a candidate in the early campaign and true population proportion of voters supporting a candidate late in the campaign. So what we're saying is the true population proportion supporting the candidate early in the campaign is the same as it is late in the campaign. Here we're saying the population proportion of voters supporting the candidate early in the campaign is greater than it was later in the campaign. So you need to kind of understand what you're actually saying when you write those hypotheses. So conditions, both are random samples, all right? Well, that wasn't given, but we're going to have to assume that they are, and we must assume that they represent the voting populations. Now, they will tell you that they're simple random samples, but if they weren't, you would say that they represent the voting populations truthfully, and we may proceed with caution, et cetera, but they're going to tell you that unless it's a multiple choice. Next thing, reasonable to assume that the polls are independent, as one poll should not impact that of the other. That's probably true. N is less than 10% of the population, 800 divided by 0.1. Reasonable to assume that there are more than 8,000 voters. And over here, reasonable to assume that there are more than 10,000 voters. Well, in the first poll, we had 460 supporting them. So that's where that comes from, where we have 800 minus 460 is 340. So 340 are not in favor. Later in the poll, we have 520 in favor. That's greater than 10. And then we have 1,000 minus 420. So 1,000 minus 520 is 480. That's also greater than 10. both samples are large enough to use a normal approximation. We still don't have p hat, and we're going to go ahead and calculate that. So p hat 1, number of successes divided by the sample size. P hat 2 is simply number of successes divided by that sample size. Number in favor of the candidate over the poll size, number in favor of the candidate later over the poll size. All right, so we need to go ahead and calculate p hat combined. Well, p hat combined is x1 plus x2 over n1 plus n2. So in this case, we basically have 980 over, it should have been 1,000. So we should have basically 980 over 1,800. And if that equals 0.544, all right? And then 1 minus 0.544 is 0.4556. So we're going to go ahead and start plugging in. There's p hat 1 minus p hat 2. So this is p hat 1 minus p hat 2. And this is our best estimate for our first population. This is our best estimate for our second population. This is our p hat combined. This is 1 minus that over n1. P hat combined, 1 minus that over the second sample size. So let's go ahead and run this test. Stat test. And we're going to drop down to 2 proportion z test, which is number 6. And what did we have? Well, we had in the first poll, we had 460 out of 800 supporting the candidate. Later in the poll, the later one had 520 out of 1,000 supporting them. Oops. Please make sure you know this. X1, N1, X2, and N2 must be counting numbers. They must be whole numbers. When we wrote our our alternative hypothesis, we had a greater than, because we think that he had more support earlier than he did later. He said some unfortunate things. Oops. Stat test 6. I'm going to go ahead and calculate. And I end up getting a Z of 2.328 and a P of 0.099. I want to talk about everything I have there because we have a lot of stuff here. This P is my P value. That's obviously P hat 1, which we have as 0.575. P hat 2, we have that. And it actually shows P hat combined. So you're asking yourself, well, gosh, if it does all that work, do I need to show it? So yes, you absolutely have to show where this came from, right? You absolutely have to show where that came from. And then you also, of course, plug it into the equation. All right. So our Z is 2.328, and we have a 0.0095 as our P value. Our P value is 0.00995, which is less than our alpha. Second, let me recalculate that. All right, so less than our alpha, they gave us a significance level of 10%. Whenever it's less, we reject. All right. So our P value is 0.01, we reject the null. There is sufficient evidence at alpha equal 0.10 to suggest that the true population proportion of voters in favor of the candidate was greater, that comes from HA, earlier in the campaign than it was at the end of the campaign. It appears the candidate is losing support, or we can confirm that the candidate is losing the support. This sample indicates that the candidate is losing support. Make sure you always have some clarifying statement where you explain what it is that you found, that you don't just go with that. All right, that you don't just go with the concluding statement. Let's include the including statement, but you need to also summarize it in simplified terms. Appreciate you for watching. We'll have one more video on two sample proportions, and I look forward to seeing you then. Thank you.